Hello everybody, welcome back. Today we are going to talk about conjugate acid and base pairs. This is Unit 10, Lesson 3, the third unit in this lesson. Yesterday we talked about the different theories of acids and bases, and today we're going to focus in on one specific theory, the Conjugate theory, and how it relates to conjugate acid-base pairs. So, it looks like there is no homework tonight. Just make sure that you're actually checking the calendar on the website, because the day that these are made are not the day that you are watching this. Okay. So, just a kind of quick recap of what you need to know from yesterday. In the Conjugate theory, we talked about how bases accept H pluses and acids donate. And so, we had bad. So we said that bases accept, and then acids donate. And we're talking about that H plus. A conjugate base is what remains when the acid gives up that H plus, and a conjugate acid is what is formed when a base accepts that proton. Remember, a proton is the same thing as H plus. Yesterday we worked out how that was the same, and you'll see that again in a day or so in something else. Okay, so this video kind of follows the conjugate pairs practice questions sheet. So let's work through this together. So the first thing you want to do is find your pairs. So find the things that look like each other. So yesterday we talked about when you're conjugating verbs in, let's say, French or Spanish, they all look a little bit different, but you can all tell they're part of the same family of words. So here, HClO4, you want to find what it looks like on the opposite side of the reaction. And so those two are going to be a pair, as they look pretty similar to each other. Next, you want to find the other pair, and so that's water and H3O+. So those are your two pairs. So now you want to figure out which one's the acid, which one's the base, and then which is your conjugate acid and or base. Okay, so looking at the HClO4 example, how did we get from HClO4 to ClO4 minus? What happened? If you said that, hey, you have to lose or donate an H plus in order to make it to that final product, that is absolutely correct. So if something donates or loses an H plus, that is an acid. Now once that acid actually donates and loses that H plus, then you get your conjugate base. So that's what we mean by conjugate acid-base pairs. The one will be an acid, one will be a base, and all that's different between the pair is 1H. Okay, so looking at the next one, in order to get from H2O to H3O plus, you have to gain or accept an H plus. And so if you can accept an H plus, that makes you a base, and that makes that a conjugate acid. Okay, so this is the same question, just broken up a little bit differently. Let's put this over here to make that easier. Okay, so going back, we said, this was our pair, and then this was a pair, and that this was your acid, this is your conjugate base, this is your base, this is your conjugate acid. So let's kind of look at how it breaks down on this sheet. So which compound will donate a proton? And so we had said that is what HClO4 does. In order to get to its counterpart on the opposite side, it has to lose or donate that HClO4. And then what will it look like after it donates? That's ClO4 minus. So once that acid actually lost that H, that is what it now looks like. So which compound will accept? So in order to get from H2O to H3O plus, you have to accept that H. And then once you actually accept it, it looks like H3O plus. So when you fill out your chart, it looks like this. HClO4 is your acid. Then your conjugate base is ClO4 minus. And your base in this case is water. And then its conjugate acid is H3O plus. Okay. Moving forward. Okay. So we want to find our pairs. The lovely perks of working outside is the traffic noises that occur. So, as I just highlighted, those are your two pairs. So H2SO3 and HSO3 minus, and then H2O and H3O plus. So following the purple line, this one, in order to get to the other one, loses or donates H plus. And this H2O has to gain or accept that H plus. So if you're gaining or accepting an H, that makes you a base, and that makes its counterpart a conjugate acid. And then if you can donate an H, that makes you an acid, and then that other part of the pair is the conjugate base. So if we look at it in this form, which one actually, so let's highlight our pairs again. So which one will donate? It hasn't done it yet, but has the capability of donating that proton, and that's H2SO4. And then once it actually does that donating, it looks like HSO3 minus, this is HSO3. Okay. Which compound will, or has the capability of accepting a proton? That is H2O. And then once it actually does the accepting, it looks like H3O plus. So then we can fill in our chart. H2SO3. HSO3 as that conjugate base. And then here, water is acting as your base. And then H3O plus is your conjugate acid. So once you do this enough, it will click faster and easier. Okay, next one. Again, first step is finding those pairs. So find the things that look like something on the other side. Okay. So it will not always look like the outsides with the outside and the inside with the insides. That's just how it just happens to be written. Okay, so in order to go from HC2H3O2 to C2H3O2 minus, the first thing had to lose or donate an H plus. Remember, if you have the capability of donating an H plus, that's what makes you an acid. So then its conjugate base, so what it looks like after it donated that H plus, is that last product. And then looking at the water example, in order to go from H2O to H3O plus, you have to gain or accept an H plus. So in order to gain, when you can accept an H plus, that means you are a base. And then once you actually do that accepting, that is your conjugate acid. So if we look at it in terms of the worksheet, Which compound donates the proton? Well, that's this. What does it look like after it donated? C2H3O2 minus. Again, the only thing different between those two things is an H. Then H2O can accept a proton, and once it does, it looks like H3O plus. So if we're filling out our chart, we have this as your acid, and C2H3O2 minus as your conjugate base, H2O as your base, and then H3O plus as your conjugate acid. Okay. Next one. Again, we want to find those pairs. Finding those pairs looks like this. And then choose a different color. Okay, pair 1. And then pair number. Okay. So, looking at the pink pair, or a purple, whatever you want to call it, in order to get from H2S to HS, you have to lose or donate an H+. So that means H2S has to lose, in order to become this, has to lose an H+. So, or donate. Losing and donating are going to be using synonymously. If you can donate an H+, that makes you an acid. And then once you look what you look like after you've actually donated that, that is called the conjugate base. And then looking at H2O to H3O plus, in order to go from one to the other, H2O had to gain or accept an H+. And if you can accept an H+, that makes you a base. And then what you look like after you've actually accepted it, that is your conjugate acid. So if we fill in this, H2S has the capability of donating a proton. Once it actually does donate it, it looks like HS minus. And then here, your water has the capability of accepting an H+, and once it actually does get that H+ accepted, it is H3O plus. So if we fill in our chart, H2S, HS minus is that pair, and then H2O and H3O plus as that one. Okay. 2 more. I'm gonna write this over here. H2SO3. Thank you. Okay, so again, step 1, find your pairs. That's 1. That's your other pair. Okay, so following the blue line, in order to go from HF to FH minus, you need to lose or donate an H+. If you can lose or donate, that makes you an acid. And then once you're done actually donating that, you are your conjugate base. So if we're looking at H2SO3, in order to get to H2SO4, this has to accept an H+. So if you have the capability of accepting an H+, that makes you a base, and that makes what you look like after you've actually accepted it the conjugate acid. So filling in this chart, HF will donate that proton, and once it does, it looks like F minus. And then HSO3 minus can accept a proton, and then once it actually does, it looks like H2SO3. On the answer key, I accidentally wrote SO4. My bad. Oops. Okay, so it should look like HF, F minus, HSO3 minus, and H2SO3. Just a side note, H2SO3 and H2SO4 are completely different acids. So the only thing that should be changing is an H. Okay. Oh, I hate formatting problems. H2S. Thank you. Okay. Last one. Finding your pairs is your always first step. So now, in order to get from HNO2 to NO2, you have to lose or donate an H+. And then if you have the capability of donating, that makes you an acid. And then what you look like after you've actually donated, that is your conjugate base. And then to follow the green path, in order to get from HS minus to H2S, you have to gain or accept an H+. And if you have the capability of accepting, that makes you a base. And that makes what you look like after you've actually accepted it a conjugate acid. So if you are filling in this, HNO2 has the capability of doing the donating, and once it donates, it looks like NO2 minus. And then HS minus has the capability of accepting, and once it actually does accept, it says it looks like H2S. So if you fill in your table, you get HNO2 as your acid, NO2 minus as your conjugate base, and remember the only difference between those two things is one H. HS minus will be your base, H2S is your conjugate acid, and again, the only difference between those is one H. So we are going to practice a little bit more tomorrow, so hopefully this helped. And to leave you on, or leave you with rather, a meme about this, enjoy this, because again, everything that we've talked about today is all in terms of what happens to H pluses, whether or not they're accepted or donated. If you're accepting something, accepting an H plus, you are a base, and if you can donate it, that makes you an acid. Again, have a wonderful day.